Embedded system challenges and performance analysis. So first, challenges in embedded computing system design. First challenge is, how much hardware do we need? Hardware include the type of microprocessor, the amount of memory, the peripheral devices, the connection devices and such devices. Our aim is to design or develop an embedded system, and it must be working provided two criteria must be met. First one is the performance deadline. We'll be deciding a time period within which our embedded system must be developed and it must be working. And the second criteria is the manufacturing cost. The cost is also decided. These two criteria must be met. So the choice of hardware is very important. If we use too little hardware, then the performance will get affected and our system will fail to meet the deadline. If we use a lot of hardware, then the cost constraints will not be met because it will be more expensive. This is the first challenge. Second one is how to meet the deadlines. So a deadline is a time period within which our embedded system must be developed and it must also be working. So one of the method to meet the deadline is to speed up the hardware. When we speed up the hardware, the program will run much more faster. But here the challenge is the system will become more expensive when we increase the use of hardware. So this is the second challenge. Third challenge is how to minimize the power consumption. When the power consumption is really very high, the heat dissipation of the system will be very, very high. It will have a negative impact on the performance. So one way to reduce the power consumption is to run the system slowly. But when we slow down the system, the performance will get affected as we will be missing the deadlines. The time period within which we have to complete will get exceeded when we slow down the system, and the performance will get affected. Next one is how to design for upgradability. So in our daily lives, people are more comfortable with updations. For example, in our mobile phones, etc., we'll get new updations. So one of the challenges is to design a system, design an embedded system with more features added. That is, we can change the software and we can add more features. But at the same time, it should provide the required performance. The required performance must be met, and we have to add more features and that we haven't written yet. And we have to make the system more upgraded. So this is another challenge. There is also one more challenge, that is reliability. When we will be selling the products, customers will be expecting to buy the products that will work really well. It must be reliable. For example, in some safety critical systems, etc. So we must be looking for reliable products. Development of reliable components. Reliable systems. Then now we'll be considering some factors, that is nature of the embedded computing system. How it will make the system design more difficult. Nature of the embedded computing machines. Under this, there are three main points. First one is complex testing. It is said that the running of an embedded system is generally more difficult than typing of the data. This is because we cannot separate the testing or the working of an embedded computer from the machine in which it is embedded. The testing of an embedded computer cannot be separated from the machine in which it is embedded. So complex testing is a challenge. Testing process is really very difficult. Next one is limited observability and controllability. The embedded computing systems we use does not actually come up with a keyboard and screens. So it is very difficult to know what is going on inside the systems, or it will affect the system's operation. We must be continuously looking on the electrical signal values on the microprocessor bus to know what is going on inside the system. And in real-time applications, it is very difficult to stop the system to understand what is going on inside the system. This is again a challenge. That is, we cannot always stop the system in real-time applications to see what is going on inside the system. That is said by limited observability and controllability. Next one is the restricted development environments. The development environments for the embedded systems include the tools used to develop the software and the hardware. This developing environment is limited in the case of embedded systems when we compare with those available for PCs and workstations. So these all are the challenges of an embedded system. Next is performance in embedded computing. The performance goal of an embedded system is to meet the deadlines. We have to meet the deadlines within which deadline is the time period within which we have to complete the development and the working of an embedded system. Within that deadline, we have to meet the deadline. The science and art of programming so as to meet the deadlines is called real-time computing. Now we will be considering a case if suppose the computation is not complete within the fixed deadline. We will fix a deadline and our computation or our working of an embedded system is not completed within the deadline. Then our system will fail even if we'll get the output, the desired output. That is the output is functionally correct, but our system will fail to work. Now we said real-time computing is the art of developing an embedded system, and the embedded system should meet the deadline such that the embedded system must meet the deadline. So this real-time computing of an embedded system depends on mainly 5 layers. The 5 layers are CPU, platform, program, task, and multiprocessor. CPU highly influences the behavior of a program. The CPU can affect how the system works and it can affect the performance. Second one is a platform. Platform will include all the components that surrounds the CPU. This include the input-output devices, the bus, connection bus, etc. Because these are responsible for feeding the CPU with signals or inputs, etc. And the CPU, it will affect the performance of the CPU and performance of the system as a whole. Next one is program. It is said that CPU, suppose we are writing large programs, it is said that CPU can only see a small window of program at a time. So we must consider the structure of the entire program because it will affect the performance of the system. Next one is task. Several programs may be running at a time by a CPU. So it is said to be multitasking system. These programs, that is these tasks, may interact with each other in different ways. This may also affect the performance. Last one is multiprocessor. Many embedded systems, rather than having a single processor, it may have large number of processors. This may include multiple programmable CPUs as well as accelerators. So, an embedded system may have more than one processors, that is CPUs, and these processors will interact with each other, thus adding more complexity to the process of analysis of system performance. There will be more than one processors and they will be interacting with each other, adding more complexity to analysis of overall system performance. This is about the performance of an embedded system.